Hello students, today let us see distributive inequality in a lattice from the chapter lattices and Boolean algebra. Statement is this: A star B plus C is greater than or equal to A star B plus A star C. Similarly, A plus B star C less than or equal to A plus B star A plus C. Actually, we have to read it as related to, but here we can understand it like a less than or equal to inequality. And if equality exists for all the elements A, B, C, then the lattice is called distributive lattice. But in general, equality cannot hold, only inequalities can hold. Now, what we are supposed to prove, let me take it again. Now I am going to combine A with A star B, then A with A star C. From that I am going to write a result. Similarly, I am going to compare B plus C with A star B and B plus C with A star C. This is the technique you have to remember. So first compare A and A star B. If you compare A and A star B is smaller than A. Similarly, compare A and A star C, then A star C is smaller than A. So we have two inequalities. From these two inequalities, what we obtain is this: A is an upper bound for these two elements, A star B and A star C. And one thing is very clear: if we are given two elements x comma y and asked to find an upper bound, we can immediately tell the least upper bound x plus y, which is the standard upper bound. So for A star B and A star C, the standard least upper bound is A star B plus A star C. Now if we combine these two results, A is an upper bound, A star B plus A star C is the least upper bound, we can say A is greater than A star B plus A star C. This is the least element and this is greater element. So we have inequality 3. Now I am going to combine B plus C with, compare B plus C with A star B and B plus C with A star C. B plus C and A star B I am going to combine with through the common element B. B plus C is greater than B and B is greater than A star B. So by transitive relation we will have B plus C is greater than A star B. This is the fourth inequality. Similarly, compare B plus C and A star C through the common element C. B plus C is greater than C, C is greater than A star C. So B plus C is greater than A star C. This is fifth inequality. Now if we combine 4 and 5, B plus C is an upper bound for A star B and A star C, and we know that the standard upper bound, least upper bound for these two elements A star B and A star C, that is A star B plus A star C. Now if we compare these two, B plus C is greater than A star B plus A star C, since this is the least element. So this is inequality 6. Now I am going to take 3 and 6 again. So if we take 3 and 6, 3 is here rewritten and 6 is also rewritten here. Now if we combine these two inequalities, this element A star B plus A star C is a lower bound for these two elements A and B plus C, and we know that for any two element the greatest lower bound is the star element, the meet operation. So A star B plus C is the greatest lower bound for the same two elements A and B plus C. So if we compare these two, this is a greater element, so A star B plus C is greater than or equal to A star B plus A star C. We get the first inequality, distributive inequality. Similarly, we are asked to prove A plus B star C is less than or equal to A plus B star A plus C. So compare A and A plus B, A and A plus C, similar proof. So A is less than or equal to A plus B, A is less than or equal to A plus C. So A is an lower bound for A plus B comma A plus C, and the standard lower bound is greatest lower bound A plus B star A plus C for the same two elements. If we compare these two, A is less than or equal to A plus B star A plus C, since this is the greater element. Similarly, compare B star C and A plus B, B star C and A plus C through the common element B and C. So we'll have B star C less than or equal to A plus B B star C less than or equal to A plus C. So we can say B star C is an lower bound for A plus B and A plus C, and we know the greatest lower bound A plus B star A plus C is the greatest lower bound. So when we compare, we will have B star C less than or equal to A plus B star A plus C, since this is the greater element, and this is taken as inequality 12. Now combining 9 and 12, 9 and 12 are rewritten here. We can say A plus B star A plus C is the upper bound for these two elements A and B star C, and A plus B star C is the least upper bound. When we compare, we will have A plus B star C is less than or equal to A plus B star A plus C. So this is the second distributive inequality. With this, the problem is over. Let us see another theorem or problem in the next video. Thank you.